Hey guys, I'm Jose and this is tutorial number 10, I think, um, in Rhino script. And today we're going to see vectors. This is perhaps one of the most fundamental elements of math that you will be using constantly through the scripts in Rhino to actually get different points and different coordinates to move around the model. And if you get a good solid base of vectors, it will become much easier to understand and move forward, uh, working with geometry and different things. So let's try to clarify some concepts on vectors. And so let's start by um, import the Rhino syntax, as usual. And we're going to create two vectors. Um, by getting objects from the screen, right? So we're going to say something like pick point for one, and we're going to specify by the filter 0 that we can only pick a point. So basically a vector is a point, but it also contains directionality and magnitude, right? Now we're going to understand those concepts in a second. So let's make a copy out of this, and let's call it vector 2 and pick point 2, right? So uh, so let's go now into the canvas. I'm here in the top view, right? So if you are, there's some point over there. If you're not, just go to the top view because this will become much clearer if we kind of work this way. And what we're gonna do is just draw a line from 0, 0. I have grid snap activated. Let's draw, let's say, one here and another line here, right? I'm going to change layer and I'm going to add a point at the end of each one of these lines, right? So what we're seeing is that we have these points that I'm going to select, and we're going to start doing some vector math with them to understand the vector math, right? So I'm going to just move into a new layer, and I'm going to make that layer green as our result, right? So this is going to be our vector 1, and this is going to be our vector 2, right? So let's see if this is working. Pick first point, pick second point. Fine. Great. So let's start doing some vector math and understanding what does it mean, each one of these operations, right? So we're going to say vector 3, the result of our operation. It's going to be rf dot vector add. You can see that if we type vector, we have several operations that get to do with vectors, right? So we're going to use vector add. It's quite straightforward, and we're going to add vector 1 and vector 2, right? If we would run this now, we wouldn't see anything because a vector would be basically a list with three values, three coordinates, and basically the definition of a point. So what we want to do here is just say rs dot add point. So we're going to add a point in vector 3, right? And let's run this and understand what is going on. So what we're saying is pick the first point, the second one, add those two together and show me what is the result of that. Okay? Pick the first point, pick the second point, and if we look at our canvas now, we have this point as a result. If we understand vector math, what this is saying is pick this point and add them together. Why did I draw these lines in the first place? It's because precisely what is going on is that if you imagine this line connecting 0, 0 with our point, and we move it on top of the first point, you'll see that we get the resulting point of the operation. Right? So it's very intuitive in a way, like if you imagine this line moving, how these two together would generate this third one. The same thing would happen if we do it this way, right? Vector 1 plus vector 2 generates vector 3. Our vector 3 is this line connecting 0, 0 and this point. Don't get me wrong, the vector is a point, but the magnitude of the vector is this length, and the directionality is, it's not here, but it's this arrow, right? So that's the resulting vector of this operation. Let's remove that. I hope that addition makes sense. I'm gonna grade that out, and I'm gonna do another one. Vector 3 equals rs dot vector. Let's see what else we have here. I'm not gonna go through all of them, but the main ones. Vector subtract, right? And we're gonna say vector 1, comma, vector 2, same thing. And we're gonna print the result. So this is the opposite, like the subtraction. So we're gonna pick point 1, pick point 2, and we're gonna go and check in the screen what's going on. Where is the vector? It's here. So that you can see it. I'm gonna draw it so you can see it better, right? So what's going on here? Why is this, if I subtract vector 1 and vector 2, why do I get this vector over here? Well, it's quite easy to imagine it if you do the following. The subtraction is basically it's a line between these two vectors, right? I'm drawing that line, and then I'm picking that line and moving it here. And that's exactly the line that we're getting, right? So the way in which you could actually, like very graphically, without doing any of the math of the coordinates or anything, just graphically understanding what is the subtraction between vectors, just imagine it as that arrow or that line that connects the 2 points, and just take that line basically back with the base in 0, and you will get the vector that it represents. It's important to know that the vector subtraction, it's not as addition like the same result if we do it the opposite way, right? So if we say vector 2 minus vector 1, and we do it again, we can go and see that the result is over here, right? We draw that again, will be that vector. What is the logic of this? Again, is the idea of the line between those two, but now we're taking it from the other side and put this one in 0, and we get the result that we were looking for. So it's very important which one is first and which one is second, because that will determine the direction of the vector that you're producing, right? The direction in this case is in this direction, and the opposite direction would be in this way, right? So I always encourage students to just understand visually what the vector addition would be by picking this line and putting it on top, and the subtraction by drawing that line between those two and displacing it back to the 0 origin. Let's remove this and let's do some other operations. Rhino has another method that I'm just going to mention it, but it's exactly the same than vector subtract, that is vector create. Vector 3 equals rs dot vector create. If anybody knows how this method is anything different than vector subtract, please let me know. Right, so vector create is basically saying we'll create a vector between vector 1 and vector 2. Right? And I'm going to pick the vector 1 and the vector 2. And if I go and check, the result here is exactly what we did before with subtraction, right? I'm just drawing this line, picking it, moving it back into the 0, 0 coordinate, and this line here is the result of that subtraction. If you don't really understand what's going on here, just do the math, right? Like pick the coordinate of x and subtract the coordinate of y. You can do that easily with this grid, so you know that x is 2 and here x is like 8, 7. And do the math and then subtract that and then do the same for y, and then you realize that the coordinates is here. But this is what is great about vectors, that it's a more intuitive way of actually working with those operations, those math operations. Let's see something else. Let's forget about vector 2 for a second, and let's work with vector 1. I'm going to just add a point in vector 1, right? I'm going to create out vector 2 as well. But I'm going to do a few operations here to vector 1 as it is. I'm going to say rs dot vector scale, and it tells us, please specify the vector that you want to scale. I'm going to say vector 1, and I'm going to scale it by 0.5, right? And then I'm going to add a point in vector 1. So let's see. Please pick vector 1, and if we go and see the result, right? So what we need to do here is override vector 1 by saying vector 1 equals this operation, right? Because if not, we won't be doing anything to the vector really. So let's see. So please pick vector 1. That's vector 1. And if we go and see the result, now vector 1 has been scaled by half of its length, right? The length is the distance between the point and 0, 0, and half of its length is here, right? So that's what the vector scale is doing, right? There's another operation that is very common between vectors. That is vector let's look for it, vector unitize. And vector unitize, what it's going to do, and I'm going to comment out this line, so we're just looking at vector unitize. Let's remove this one from the screen, and let's see vector 1. And if we go down, we'll see what is unitize. Unitize is actually making this vector 1 unit in length, right? So this point here is at 1 unit of the 0, 0. And you might be wondering, like, why do we need a vector of 1 unit? Why would we need that? Well, the thing is that if we want to just get a vector in the same direction but with exactly 3 units, we would first unitize it and then multiply it by 3. So let's do something like that. So what if we want something that is exactly 8 units, right? So we could say vector1 dot unitize, so it goes back to 1 unit of magnitude, and then vector scale by 8. So we will be saying 1 times 8, 8. So we're gonna get a vector that is precisely, let's see, if we distance, calculate the distance between here, and we have 8 meters, right? So we're creating a vector that is exactly 8 units in the direction of this first vector, right? So we're combining here these two operations, unitize and scale, in order to achieve this point. I'm gonna do a last example to when I'm gonna put these ideas together, right? So what if I would like to get a line from this vector looking at this vector of 2 units in this direction, right? So we would have to do the following operations. So we're gonna bring back vector 2, and we're gonna say first what we need is vector 3 would be the subtraction between vector 2 and vector 1, right? Let's remove that. Then vector 3, we are gonna unitize it. Vector 3 here, we're gonna unitize it. So the first operation is just getting that vector, the directionality of the vector, right? The second stage would be unitizing it, so make it really small, like 1 unit. Then we're gonna scale it by the size we want. In this case, it's 2 units, and it's vector 3. Just remember to just overwrite the vector we're working on. And at the end, I'm gonna add vector 3, vector add, and vector 3 to what? To vector 1. Let's see. And we're gonna draw vector 3, right? Let's see. Pick the first point, pick the second point, and what do we have? We have a line, a point somewhere in space that is, if we draw the line, the whole line till this point, we see that the direction of this point is pointing out towards that other point. But if we type length here, we can see it's 2 meters, right? So we combined all these 4 operations and in order to achieve a point at 2 meters from this one, looking at this other one, right? So again, let's go through what we did. First was the vector subtraction. If you remember, the vector subtraction was this line, and I'm gonna do it graphically so you can just see what I'm doing. Subtraction, that's the first operation, right? You can leave it here. I hope you can see that. So subtraction, we draw that line and we pick that line and we move it to 0, 0. Second, unitize. So we do basically like something over there, like it becomes small, 1 unit, unitize. Then we scale this guy up by 2, like 2 units, something like that, right? And then we vector add this vector 3 back to vector 1. So we say move again here. So this is the 4 operations, the algorithm that will give us a point looking at this other point. So yeah, this is the basic of vector math. That would be, as you've seen already by typing rs.vector, and you'll see that there are many other operations related to vectors, and we'll be seeing some of those as we're moving along. But mainly these are the operations that you will be using all the time, to just build directionality and understand some of the tangents and some of the concepts of geometry that get to do with vectors. And that's it.